Good afternoon, everyone. Welcome to our session. We're really glad to see so many people here, considering it's Wednesday, 3 o'clock, and we all can't wait for the data night out, I'm sure. So we'll start with a quick introduction. My name is Alex, and this is my colleague. His name is Alex as well. We're both based in our European office. So as part of the introduction, I would actually like to show you something. This is the very first dashboard that I built after I joined Tableau. And maybe some of you could recognize this city, or the map of the city. Any ideas? Guesses? London, yeah, that's right. So that's where we live. And the point of building this dashboard was I'm kind of the guy, I just don't like waiting for things. And when I go to the airport, I always turn up at the very last minute. Even when we were preparing for the session, actually, we were like very late to submit our draft. And so when I built it, so the reason why I built this dashboard, I was looking at taxi rides in London and was trying to figure out. So this data is actually scraped from one of the apps, taxi apps. So this is my own data, also data from my colleagues, and the point of that was to trying to work out whether it's quicker to walk, because traffic sometimes can be really bad in London, or to get a taxi. Okay, so now I'd like Alex introduce himself.
He skipped the last part. You know that there's many taxi companies are disappearing from some cities, so I don't know if you were involved or not. But anyway, the other thing that he didn't tell us is that we have 5 Alexes. Is it 6 or 5? 5, right? I'm losing even the account. 5 Alexes on the team. Obviously, if you're looking for the most handsome guy, that's Alex Lokov from Russia. You see the beautiful smile. Yeah. We have 2 British guys, and we have a German guy, and we have a Brazilian guy who goes by a Turkish surname, Eskenazi. That's me. So I focus on the Middle East region. Alex is covering the Nordic region. Yeah. And Alex told me to tell you a fun fact about me. I don't know if that's fun, but I have this crazy thing that I like to track everything that happens on my devices and optimize my devices. And for example, so on my phone, I track what kind of apps are stealing the battery the most. On my computer, I have this gauge here, and I'm seeing all the CPU activity and all kinds of things, memory, what's eating up the processor. I should have done that. And even at home, I'm tracking how many times my wife leaves the lights on in the kitchen and how much it's costing. But I really don't recommend doing that at all. Bad idea. But the point is, last year I saw Alex playing with some tools in Tableau and tracking all kinds of things Tableau was doing in real time. I'm like, wow, we can talk about that. We can leverage that. So that's the point of this session today. We'll be showing you our experience from the field on how we manage to help clients leverage Tableau's data points and tools that Alex will introduce to you in a minute, his secret weapons, and yeah, how to optimize Tableau in general. But this session is packed with information, so we encourage you to write down any questions you have, because we'll have time for questions at the end, right? And maybe, Alex, could you start by opening up a bit? What do we mean by optimizing?
Sure.
Enhancing queries.
Okay. So to give you some context, this session, so performance in general is quite a wide subject, right? So there are many things that you can do in Tableau to improve performance. It's not just queries. There is workbook design, calculations, and things like that that would that would affect performance as well. So this session is specifically about database queries, right? So the thing on the right is a very badly written calculation, but that's not something we're going to cover today. So this is the agenda. We kind of If we had a bit more time, we would probably rename our session to like 10 tips for optimizing queries. So that's kind of just to help you navigate and measure the progress where we are with this. And so the first thing we would like to talk about is actually tools of the trade, right? So the idea is like when Alex and I would go and meet with clients, what we find is we as Tableau take things for granted. Like we just assume that our clients actually know what tools we have at our disposal. And it turns out that it's not always the case. So as a very quick overview, I just wanted to show you literally 2 tools that we kind of use for to understand what happens under the hood when we look at queries in Tableau, right? So the first thing I'm going to do is I'm just going to start a new instance of Tableau Desktop. And I'm sure many of you are already aware of this thing, but I still find clients who don't know about this. So the first tool I would like to talk about is Performance Recorder. Right? When I open Tableau Desktop, this menu over here enables me to start performance recording, and this is what I'm actually going to do now. So I'm just going to go and start this, and now I'll go and just open a workbook like I would normally do. So what's happening now is this is a workbook that has a live connection to a database, and when I'm opening this workbook, Tableau generates queries and sends those queries to the database. When the performance recorder is running in the background, Tableau actually collects information about all the queries. And when I'm done, and I would like to go and investigate what actually happened, I can go and click Stop Performance Recording. And this is what I will see, right? Tableau actually generates a new workbook for me. And this is what it looks like. Essentially, this is kind of a summary of what happened, in this case, when I opened my dashboard, right? So you see here, at the top, it's kind of a Gantt chart. You see there is time on the x-axis. You see this gray bar over here is how long it took to open and render the workbook from the very beginning to when I saw the final result. And the orange bit is when we're connected to the data source. The bit that we're interested in for this session is specifically query execution, right? So these are these green bars over here. And this is what we'll be looking at today. So if I wanted to know something about each one of these queries, I can actually go and click on it, and I can see the actual SQL that was generated by Tableau, right? So this could be very handy. A really, really good tool, and it's actually built into the product as well, right? So I kind of encourage you to use this tool as the first kind of a tool for any troubleshooting. So there is one other tool that we'll be using today, and it's kind of a less well-known. This is what it looks like. It's called Tableau Log Viewer. It's actually a community tool, which is available on our GitHub page. So it's not kind of an official commercial product, but it's actually developed by people at Tableau. And the reason why it's useful for sessions like this is, I will just show you in a second. If I go and still look at my dashboard, for example, and I try to do something as an action. So let's say I just want to go and click on a region. You see what's happening here? It's like a real-life telemetry of what's happening. So it's not like Performance Recorder where I go and retrospectively investigate what happened. This actually shows me in real time which queries are being generated at Tableau. So again, this is very useful when you deal with dashboard actions and you just want to find out what exactly Tableau is doing against the database. This is quite a good way of doing it. So for instance, these are my queries. I can just go and click on the first one. I can actually see the SQL, again, that was generated. But this is actually real-time telemetry data. So just for your reference, we kind of, obviously the slide deck will be provided to you. Performance Recorder we talked about. Tableau Log Viewer, this URL at the bottom is our GitHub page where you can actually go and download this tool. Right, so let's talk about the actual queries. So first thing we'd like to talk about is custom SQL. So naturally, when people hear about optimizing queries, they usually think about SQL, right? So I want to go and write my own SQL, which is going to be better than Tableau and better than anything else, and it's going to be optimized for my particular database. So this is something that we see in the field from time to time. And in general, we don't recommend doing it, but sometimes we don't do a very good job at explaining why. So I'm just going to show you very quickly what happens when you actually create custom SQL code in Tableau. I'm going to go back to my dashboard. And just to show you what the connection looks like, so I'm connecting to a Microsoft SQL database. The data that we're using, some of you might be familiar, it's a TPCH data set. This is like commonly used for database performance. Actually, it's not Tableau specific, but we thought we'll use it because many people are familiar with it. So what we've done here is we've kind of created this schema in Tableau. You see this like a traditional, kind of a fact table and dimension tables, which are all joined together. And this is like one way how you can build your schema in Tableau. And the alternative to that would be to go and actually write your custom SQL. And this is how you would do this. So this is this button over here. Instead of like dragging these individual tables into the view, I can actually go and write my own custom SQL code. So in this example, I'm not going to do that. I will just let Tableau do it for me. Right, so you see this is Tableau generated this custom SQL. It's basically the equivalent of all these tables being joined together, right? And now I have this custom SQL code. So this would be like an equivalent of you writing it, yourself. So let's see what happens when I use this custom SQL as a connection to my database. I'm going to go back to my dashboard, and we'll open the log viewer, and let's just clean it very quickly. Right, so let's try to do something, I don't know, let's filter our data to sales in the United Kingdom. I'm just going to click on the particular country, and once again, I can actually see all the queries that are being generated by Tableau. I'll go and grab this query and put it into a notepad so we can look at it later on. So now I go back to Tableau and kind of undo my custom SQL. So I go back to the schema that I had in the beginning. Instead of having custom SQL code, I just have these tables joined with each other. And I'm going to do exactly the same thing. So I'll go to the, let's go to the, where's the log viewer? There it is. So I'm going to go to the dashboard. Yeah. I'm going to go to the dashboard and do exactly the same thing. Click on a country and just filter it to sales in the United Kingdom, for example, right? And this is the new query that was generated by Tableau, but this time we're not using custom SQL. We're actually using those tables that were joined with each other. And now we'll put those two side by side, so hopefully we'll see what's going on. The idea here, so now on the left, I see the query that was generated when I had my custom SQL code. And on the right, I have the query that was generated when I just had those tables kind of joined with each other in the data connection window. And hopefully you'll see the difference. We actually have a plugin that we can use to kind of visualize it a little bit better. So I can compare the two, right? So the orange bit is basically completely identical. And this is, so these are the kind of the values that we're trying to get from the database. So in this case, we're looking at the top level KPIs at the top of the dashboard. The difference is this section in the middle. You see what happens when I use the custom SQL code. Basically, Tableau creates this kind of a nested SQL query inside. And what happens is, whatever you define inside of that custom SQL code, we basically, whenever we try to decompose it, we basically treat it as a kind of an atomic fixed statement. And everything else that you do in Tableau on top of it, so things like filters or dashboard actions, we actually wrap it around, and create another SQL statement which is wrapped around the original one, if that makes sense. So it really depends on your database, how well it can handle things like that, but in general it means performance impact, right? And so that's kind of the reason why we actually don't recommend doing it. There are always exceptions to this rule. So for example, if you want to create an extract, it might be okay, because you kind of do it in the middle of the night. It doesn't actually matter how long it takes to run this query. So there could be some corner use cases where it might be okay, but in general, we always encourage customers not to do it. Okay, and just one other thing I would like to talk about is parallel queries. So this is a feature that was introduced in version 9, so we had it actually for quite some time. If I go to my performance recorder, you see here this Gantt chart with different queries. So these 3 queries, they were actually executed in parallel. So we didn't have to wait for one query to finish before we started another one. And this is something that actually Tableau does by default since version 9. So I don't have to do anything specific about this. There is only a couple of things I'd like to point out here. Again, something that we've seen in the field. It depends on the design of the dashboard. So a very common scenario is when you have filters and they kind of depend on each other. You know, when you create a filter and you only have relevant values inside of that filter. So it actually means that you have this dependency on your dashboard. You have to wait for the first query to finish before you send the next one to populate those relevant values for your filter. So be very careful with that. We've seen people kind of breaking this parallel query, and you just have sequential thing that is on the left. And the other thing I would say is it's also database specific. So this is kind of a simplified diagram of how Tableau connects to a database. What happens is you have your data source, and then we actually create multiple sessions to the database. And this is how we actually do parallel queries. So we have multiple sessions, and the number of these sessions will depend on the type of the database. So this is something that we kind of learned from the field. There are different settings. So for example, it could be different values. Usually it's between 2 and 16 parallel sessions, but really database specific. So be aware of that as well. And this is a setting that you can tweak. So there is actually a setting in the data source file which you can tweak. So if for whatever reason, let's say you have a scale out database and you know that you can handle more sessions in parallel, you can actually go and tweak that. Okay, so now I'd like to hand over to my colleague. Just continue with this presentation.
Thanks, Alex. So next point we want to talk about is joint culling. And joint culling is one more of those things that Tableau is doing for us automatically and very, very often to optimize our queries. But more importantly, it's something that all databases do automatically. And when we talk to DBAs, when we talk to people who run databases, that's something that they take for granted within a database application, but not something that they take for granted necessarily on a BI application like Tableau. So to explain what joint culling is and why is it so important, I will show you one example here. So we are talking about the same schema we had before. We have a fact table on the left with transactions, items our customers purchased on a store. And we have our dimension table on the right with the order IDs. Now, if we decide to join those two tables together based on the order key, this is what we get. And as we can see, we don't have any data loss, and we don't have any data duplication. So that's perfect. Now, if I ask the question, what's the total sales amount? You probably guessed now that we have two ways of answering that question, basically. The first one would be to go directly to line item table, and Tableau would generate this kind of query. Select sum of sales amount from line item. Now, the second option would be to go to the second joint table, and we can immediately see that Tableau is generating much more code for us. Select sum of sales from line item, inner join orders on those two tables, on the key. The answer is the same, but you and I know by looking at the table below that, obviously we didn't have to go to the join table, which could potentially take more time, right? So Join culling is that's exactly what join culling is. Join culling is removing joins from queries that don't need to have those joins in them. So in this case, if you look what that is, these tables are related to each other. For every line item, we have a corresponding order ID. So every record has a match. And on orders table, order key, every record there have one or more matches on the dependent line item table. So these tables have a relationship. If you think about what that is in database terms, is a primary key, foreign key relationship with no data loss, no data duplication. So for Tableau to be able to create this kind of query here, the simple query, we need to have that referential integrity. So that's one thing to keep in mind, that Tableau will see that there is referential integrity already set in the database, and it will create a more simple query. If there isn't referential integrity in the database, Tableau will generate that more complicated query. But then we have an option to go in Tableau and force Tableau to assume referential integrity. So let me show you how you can see these things live. And how can you tell from Tableau that there is referential integrity between tables? So in the first example here, we have line item and orders. I'm not assuming referential integrity. And I know that we have referential integrity in the database. And I go and say, what's the total sales amount? And here's the query. Very simple. It's not including order table. Now, the second case is I actually duplicated that table, a line item, and now I don't have a primary key and foreign key relationship specified in the database. So when I run that query, extended price, we get that join happening. Okay? How do you know if the database has referential integrity set or not? One quick indication would be when you perform your join here, Tableau doesn't find that join key when we don't have referential integrity. Now, in the other case, where we have referential integrity in the database, let me take the order table and join. Tableau knows there's a primary key, foreign key, and great, it does the job for us. The third thing I want to show is, okay, when we have line item table, no referential integrity, and we say, Tableau, assume referential integrity, and ask the same question, this is what we get, the simple query, which is potentially faster, because we are not bringing more tables to the join. Now, one important thing to keep in mind if you are trying to leverage that feature, referential integrity that we assume in Tableau will only be applied for inner joins and all inner joins in the connection. If we have any outer join, left join in this case, we have to include that table in every single query. So keep that in mind. So let me show you what happens now when I ask the same question. Standard price. So now we are including the parts table in the join. We didn't include orders. That was an example where I'm connecting to a database that doesn't have referential integrity, and we assume the referential integrity here. Now, if I ask a question on that table here, parts key, because we don't have to include orders in that query because referential integrity is assumed in this join. So let's go to the part key table and we say, okay, give me the count of parts. Maybe count distinct, anything. And yeah, so we don't include the order table. So This is an example of what happened in a real production scenario. A customer came to us and said, hey, I'm just really trying to list the contents of one field in the database. So we were expecting a query like this, very simple. Select field name from table. And then this was Redshift. This is the query that Redshift was generating for us. So clearly the optimizer wasn't really optimizing the query for us. And we were doing some 20 additional joins, and it was taking really long. So try really to appreciate how much more time would it take if you are not assuming referential integrity in the database, or if you can assume referential integrity, it's not enforced in the database, do it in Tableau. Now, join culling and this feature of referential integrity is an old feature we have always had in Tableau. And the thing is, from version 10, we introduced cross-database joins. So that there is a whole new, very important application for referential integrity because of cross-database joins. So let me explain you why that's the case by first introducing you how cross-database joins work. So essentially, with cross-database joins, we are trying to bring data from multiple systems. So obviously, there is no referential integrity between those fields. They are in different systems, right? It happens in 3 steps. In this case, we are getting data from 3 different systems. First step, this is one data source, right? And in this data source, we will establish a connection to those 3 systems, and we'll query data in the row level. We'll get row level data. Second step, we bring that data, the row level data, imagine how much data we are talking, potentially, to Tableau, download all the data, and we create temporary tables. And this is what we call a shadow extract in Tableau. Finally, the first step is to materialize that join in the front end, either Tableau desktop or Tableau server, and answer the query from the customer. So keep in mind that, data has mass. And moving data around is something we need to be aware. So if we are connecting to 3 systems, it's probably going to take more time than if everything is in the same system, where we can just send the queries down to the system and let the system federate, do the querying, and give us the final aggregated results, not row-level results. And then if the data is on a cloud system, it can take time, right? So that's one of the fundamental theorems of data integration you need to keep in mind always. The physical structure of the table, of the data, will affect your performance significantly. So the more data has to move, the longer it will take. The further the data must travel, the longer it will take. And obviously, if your internet speed is slow, the slower the rate of data flow, the longer it will take. We have made some tests, and we saw that roughly 70% of the time is actually just moving data around. And only 10% is really materializing those joins. So be aware of that. And let me show you what we could potentially do let me show you how this is perceived and how you can track that. So here I have the same example I was elaborating earlier, line items and orders. And then we also want to add our customers to this connection, to this data source. And we have the location, the nation table, the dimension table telling us where are these customers coming from. But just imagine if the customers are coming from another CRM system, which is quite a normal case. So in this case, even if we are assuming if the database is enforcing referential integrity around here, we can't have it here. So if I ask the same question, how many customers have placed an order? We know we could get the answer from here, or maybe, potentially we go to count the customer ID here, because we know for every order we have a customer connected, right? Our database application makes sure that we write a new order ID, and we write, if it's a new customer, we write the name of the customer in the CRM system. If we can assume that, we don't need that part at all. We can do joint culling here, right? So I'll show you now the difference between not having referential integrity enabled and having referential integrity enabled. So let's go back here. For that example, I'm going to use performance recorder. So first one, in blue, SQL Server connection, CRM system is MySQL. And assuming referential integrity is one of them. The other one is same connection, not assuming referential integrity. So the first one I will run is not assuming referential integrity. And I go to orders table and I count customers. Watch what's going to happen now. So you see the count going up? This is Tableau downloading data. And it's going to do it 3 times. We had 2 systems. It was SQL Server and MySQL. But because we have in between them another system, so we have to download that data first, the other one, and then the third one. Now, the second case would be where we have referential integrity set, count customer keys, and I'll stop performance recording, and let's see what we get. So here we have case 1, 3 queries. It's actually 4 queries if I open up a bit and keep only queries. 1, 2, 3, 4. These are the 3 tables we are downloading locally. One of them is really slow because that's where we have data coming from the fact table. Finally, we have the third query, which is our abstract query language, where we actually combine the joins. This took roughly 9 seconds, whereas the second case, it's one simple query, which took 3.49 seconds. So more than, double the time for the first one. So, takeaways, cross-database join will move a lot of data. Basically, every single filter you click in the visualization, you'll be downloading data over and over and over. So it's an awesome application, but think if you can maybe use this for small to medium data sets, and if you have a large data set, consider using extracts. The problem with extracts today is that we'll create a big denormalized table, and potentially we are losing rows, creating data duplication. With Hyper, first phase, we'll have the same situation as TDE. We'll create a big denormalized table, but on a second phase, we'll have like those tables being materialized individually. So that would be great. We won't have that problem anymore. Don't avoid DBA's laziness. If you can, enforce referential integrity in the database. If not, if it makes sense, do it in Tableau. Tell your DBA or your application developer to, become friends, you never know. And one thing to keep in mind with join culling as well, I didn't show you, but even if we have multiple tables on a connection, a data source, that filter will populate data from one field only. So join culling is always happening on filters, okay? So Tableau does that for us. No need to assume referential integrity. So that's good. Okay, you guys good to go to the next tip? All right. So forget about assuming referential integrity, join culling. Let's talk about another tip, no safe joins. This is something I learned last year, and I didn't believe it, but I tested, and it seems to be something important to keep in mind. So what is that? It's the idea that sometimes we have to make joins on fields that allow null values, okay? So here's an example. So I want to join those 2 tables. Emma is missing. We'll join on the location code, and for Emma, we don't have the location code. And say that we do have a row on the dimension table that we cater for missing IDs in the other table. Awesome. We would expect Emma to show up on our join table, right? But no database will show that missing row. So that's a thing that we call in database terms ANSI, null semantics. Nulls are not comparable, non-comparable. So basically, yeah, we miss that row completely. We skip it. Now, in Tableau, on some cases, we can get that situation. Not on all cases. With database connections, we'll never get that because databases don't do that. But there's a case when we have up to version 9, for text and Excel connections, we could treat nulls as equals, and we could return those rows. And we would do it automatically for text and Excel connectors. Now, from version 10, this changed. And the default behavior for Tableau, even text and Excel connectors, will treat nulls as non-comparable, and we won't return those rows. But we introduced a new feature here where we can tick this box, and we can say, hey, I want to get those rows. This happens only for text and Excel, and now we introduce Salesforce connector as well, which happens to have a lot of nulls everywhere because people are very bad typing information on CRM systems. So yeah, there you go. So we can enforce that. For databases, again, we don't do that. Multiple connections, cross-database joins, even if it's one Excel and one text file, it's a cross-database join, we automatically disable that capability. They are non-comparable. Why am I telling you this? Because Tableau can be really, really picky when it sees that you have joins on your data source on fields that allow no values. And what it will try to do is it will go there and put a where clause on all your queries saying, hey, test and find, execute the join where field is not null. Or if it's another database, it will try to convert and apply an NVL function or coalesce function. This can be really, really slow for every single row in the join. And this is one of the tips, like I said, I heard last year from Mr. Thomas Foldy. Some of you may have heard about him. He's at the conference. He's one of our greatest Zen masters, CTO of Star Schema. He's presenting tomorrow an awesome session on all kinds of crazy ways to hack Tableau server. You can do things with Tableau that you shouldn't do, but yeah, there you go. Go to his session if you're curious. And he said that this is one of his favorite performance chips that could improve by 50%. So I went to test. Here's our example like before. Same question, how many customers placed an order? This is the relationships we have with databases enforcing referential integrity, primary keys, foreign keys. And in here, we have a field that accepts nulls. So if I know, again, that my application is writing always the location or the nation of a customer, I don't need to worry about that, right? So if I become friends of the DBA, I'll tell them to change this field and say, hey, put not nulls. Or maybe I become friends of the database, the application designer, and tell them, hey, write, instead of nulls, put an empty string or put an NA. That's much better, So yeah, so I'm going to show you the difference. I'm going to go to my database and I'm going to change this field now because I know I don't have null values. So let's see what happens when we do that. That's going to be a live streaming demo using log viewer. So, and let me show you the database first. So this is SQL Server, and here I have the customer table where nation key accepts nulls, okay? And I run the query. Let's put my log viewer here, and let's go to orders and count distinct customers. And as I told you, it's including this where clause to test every single row in the join for nation key not null. Now, let's go and hack the database and say, okay, don't accept nulls, execute. So I'm going to refresh. Now my database, hallelujah. Let's see what happens. When I run the same query in Tableau, and so I'm just going to I have to refresh the connection because I'm connecting to the same data source, so Tableau needs to get the metadata and know, hey, this is a not null field in the database. And now I can run the same query, count distinct, customer key. And I should have checked how long time it took, but yeah, hopefully you believe me, I have a slide comparing. This took 3 seconds, the other one took 6 seconds, more or less. So it's, yeah, Tamaz was right. It's about 50%, at least in my tests. And he was testing on Redshift, and he got the same. So the next tip is on filters. And when we talk about filters, there's a lot of things that we can do if we understand the kind of queries each type of filter generates. We can try to optimize. And there's a whole section on our best practices for designing efficient Tableau workbooks, white paper about filters. If you don't know what I mean, this is a #1 white paper. You should definitely read it. We have even a whole session tomorrow where we'll do it on stage with you guys. It's a hands-on session. We'll be running through those key examples from the white paper. But I want to tell you the story about large enumerated list filters. There was an actual case I had from my client recently. And let me tell you the story first. So this was the client dashboard. And you can immediately see it's, maybe I told them many times, maybe we should look at the white paper and read, think about the best practices. And so anyway, they were saying it's 51 seconds to open, and we are very happy with this dashboard design. Stop trying to make me change my design, and that's a very, normal kind of thing to ask, right? We don't expect people to know best practices. And I don't think we should, right? But we can try to optimize by applying those techniques. So 51 seconds to open. I went to research what's going on. One data source, one single connection, so one database only, so great. 7 tables, a lot maybe, but referential integrity was enforced in the database, so all good. 15 million rows, not too bad either. 6 graphs and 10 quick filters. I was like, okay, maybe we need, maybe not, yeah. But it was generating 130 queries, this dashboard, because there were, creating beans and all kinds of crazy things. So I said, okay, let's use our lovely performance recorder tool to see what's happening behind the scenes when we open the dashboard. And this is what I got. And I was very, very happy to see parallel queries working amazingly well. And this was taking 22 seconds. The longest running query is on the critical path, right? So the database is going to perform as slow as the slowest query, so 18 seconds. But this is the block that was making me very, very angry. Why, after we get the data, do we have to do a lot of post-processing in Tableau? So I looked at those 2 big bars here, sorting data, 5 seconds, the other one 4, another one 1 second. That's really odd. So after some analysis, I noticed the dashboard design had drop-down filters, which is pretty normal, pretty good. But basically, this is a large enumerated list filter, which means when we open the dashboard, we have to send a query for every single filter to give me the distinct values for that list, right? So when the user clicks, it has the values. And after that, it has to sort those values. But maybe if you design the dashboard properly, this wouldn't be a problem at all. But in their case, they had 4 filters where they had really highly cardinal fields. like 1.5 million rows here. So why would someone bring 1.5 million rows? Which user would remember and go to a list and click, I want this, this, this. But they say, Alex, please, just stop. Just help me fix it. Fine. So I found out we have this option, which is a non-enumerated list filter, where we can actually just execute a query the moment the user needs to get the filters. In the interest of time, I'm not going to show you how this works, but basically it's also a box. You can put a space on the box, and it shows this zoom icon. You click, and then it sends the query. 5 seconds query, whatever it has to take. But then it's fine. Right? I can't wait. And it went down from 51 to 24 seconds. And I was super, super happy. Like the longest query was still taking 18 seconds, but I was happy because, come on, 53% faster. Went to my client, and he was still like, come on, Alex, you can do better. That's not, yeah. So took me another 1 day talking to colleagues, etc. And we looked at the dashboard, and it was actually just looking at data from this year versus last year, pretty common. And the database was huge. It had 10 years worth of data. So we only needed 15 million rows, but it was scanning through terabytes of data. So what we did, we added a data source filter, and I told them maybe you can apply partitioning in your database as a long-term strategy. You don't need that data very often, potentially. But in Tableau, we applied this filter, and it went down this longest query to 4 seconds from 18. We went down to 7.5 seconds. My grandma in Brazil always says 10 seconds is too much for everything. So I have to agree with the client, and yeah, he was happy. So yeah, keep that in mind. It can be a huge performance boost by remove highly cardinal fields if you can. It doesn't make too much sense in most use cases. So Alex.
Okay, that's great. Thank you. Query fusion is another feature that we introduced some time ago. And the best way to understand how it works and what it does is if I go back to the dashboard that I had in the very beginning. Let me try to find it. So notice, so it's great that we talked so far about like how you can optimize queries so they can run quicker and maybe we can execute them in parallel. But wouldn't it be even better if we send fewer queries to the backend database? And this is actually an example of, this is basically what query fusion does. So if you look at this dashboard and you think about what is the number of views that we need to build this dashboard, right? So essentially we have 6 views if you include the filter, right? So each one of the KPIs at the top is actually an independent view. So I have one for the sales, one for the shipments, one for the discount. Then if I include the filter here and these 2 views here, so I have 6 views in total, right? So my next question is, how many queries do I need as a minimum to render this dashboard? And actually, if you ask different people at Tableau, you usually get a different answer. So this is quite a nuanced subject. So I'm not going to do a survey right now because we're kind of running out of time. So the correct answer is 4, right? And some of you might be wondering, why is it 4? We have 6 views. Wouldn't it make sense to send 6 queries to generate each one of them? Actually, what's happening is these KPIs at the top, if you think about it, they're done at the same level of granularity. So essentially, each one of these queries would have a group by statement, which will determine the granularity of each view. So for example, the map would be, I would have a nation as a dimension, right? And then the SQL statement will have a group by nations clause as part of it. Obviously, these KPIs at the top, they're basically, there is no group by statement. It's just a total aggregation of all the shipments, of all the sales. And we don't need to send 3 separate queries. What we can do instead is we can say select sales, comma, shipments, comma, whatever else we need there, and there will be no group by statement there. So basically what we're doing is we're merging those queries into one. And this is what Query Fusion does for us automatically. I don't need to do anything special about this. Tableau is intelligent enough to realize that this query is actually done at the same level of granularity. So this could be really handy. But we had an interesting case last year. It was actually our professional services team in Germany. They were working with a client with a very complex dashboard. again, trying to kind of optimize performance. And the question was, can we take it even further? Right? So looking at the same dashboard, can we do something to even reduce the number of queries from 4 to something less than that? And we managed to do that. So how did we do it? So this is the kind of the answer. We actually managed to reduce it down to 2. We kind of did a little trick. I'll show you how we did it. There is, if we just go and open another dashboard, and I'm not going to run performance recorder because we're kind of running out of time. But trust me, it does generate only like 2 queries basically. And the difference between, let's just wait for it to load. So the difference between this dashboard and the other dashboard is here we're actually doing a little kind of a dirty trick, as one of my colleagues called it. So if I look at the total sales view, I actually still have this region as a dimension, right? So what we're doing is we still bring data at the lower level of granularity into Tableau. So in this case, it's actually a region. And then at the Tableau layer, we then run, in this case, a table calculation. So we actually do a running total of all the countries, all the sales for all the countries. So we just include header. You see here, these are my countries. And the very last value in my case would be the total sales, right? And this is how we basically managed to, and we did the same trick with the other 3 views. So that's the trick that we kind of basically used to bring it from the original 4 queries down to 2. And it actually depends on the database, whether you're going to get performance gain out of this, because you're kind of sending fewer queries, but potentially they're more complicated. So again, it's not always going to improve things. But in some cases, when you kind of want to get that little bit of extra from a performance of dashboard, this could be an interesting technique to use. So number 9, caching. Caching is usually something that we talk about in the context of Tableau server. Obviously, Tableau server is a multi-user environment. What we ideally want to have is if different people looking at the same dashboard, we don't want to send queries each time if they're looking at the same dashboard, the same data, right? So we want to cache data inside of Tableau. So Tableau actually does it for us. This is not like an architecture deep dive, but essentially there are multiple layers of caching that are happening. But what we see in the field is sometimes clients would ask us, is there something we can do to warm up cache? So I know that all these people will turn up at 9 o'clock in the morning on Monday. They will look at this dashboard, and what we'd like to do is pre-load the data into cache so that the very first user who opens the dashboard doesn't have to like sit there and wait for 30 seconds for it to open, right? So there is a couple of things you can do around this. One is specific to extracts. For some reason, we didn't really advertise this feature, but it was added very recently in Tableau version 10.3. We've added this feature to pre-compute workbooks. So what this is about is when you create extracts, this is usually done on a schedule. So what we're trying to do is, after we complete every refresh, we pre-populate something called external cache in Tableau. So actually, it means that all these values are already pre-calculated, pre-computed, and the very first person who will open that dashboard doesn't have to sit there and wait. If we're working with live connection, there is a little trick that, again, we kind of learned in the field, is you can use subscriptions to warm up cache. So if you're familiar with subscriptions, the way it works is you can subscribe to a dashboard, and then you will receive an email with a snapshot, like a rendered image of the dashboard. So if you know that people will be looking at this dashboard at 9 o'clock in the morning, what you can do is you can set up a subscription which will run at 8:45, which will render this dashboard, pre-populate the cache, and then the very first person opening it will be very quick. So the very last trick is not really a trick so much, but again, just kind of advice for what we learned in the field. People tend to go into the weeds very quickly, start looking at queries, ask questions about why Tableau does this, why does it do casting, or we get all sorts of like questions about specific to queries. But be aware of the bigger picture. So workbook design and calculations is something that actually is even more important, I would say, in terms of the performance. And if you think about, look at this pyramid, like things that happen at the top, so workbook design, that affects everything that happens at the lower level. So an example with filters that Alex used before, this is a perfect example of, too many filters actually affects performance of your queries and calculations as well. So yeah, just something to be aware of. So quickly to summarize, performance recorder, really cool tool, use it, and this is like something that we use on a daily basis. We always recommend our customers use it as well. It's available on the desktop as well as on the server. Not many people are aware of this, but there is a URL. When you access a view on the Tableau server, as part of the URL, you can say record performance equals yes. Like if you Google for it, you will find it. And actually on the server, you can get the same view with what happens under the hood. Custom SQL, only use it when you need it. Make sure you take advantage of parallel queries. Normally it happens automatically, but just double check, look at the performance recording, see if it actually works. Become friends with your DBA, right? Primary key, foreign key relationship is important. It's good when it's enforced as part of the database schema because Tableau will take advantage of that. Same applies to not null statements, right? So make sure that it's enforced as well if you can. Assume referential integrity is, again, a very important technique that you can use to get around it. And in particular, when you're using cross-data source joins, it becomes really, really important. The number of filters and the types of filters are really important. Actually, I would say that's like number one thing that we look at when people kind of ask about dashboard performance in general, not even just with queries. Query fusion is something that kind of happens by default. You don't really need to do anything about this unless you kind of want to use the little tricks that I showed earlier on. And warm-up cache. Like if you want to take advantage of cache, you can use subscriptions to do that. So yeah, and the last thing I would like to show is it kind of feels good when you work with a client and you help them with performance. It kind of goes back to the very first introduction. We all want to save time. We want things to happen quicker, and it almost feels like you're winning the race, right? When you get a dashboard from being slow to becoming really performant. So this is kind of what it feels like when you improve queries. So that's Alex and I kind of in the field. That's right. So this is a good time to take questions if you have any.
There first. Yeah.
When you have a really complicated database and you have one group of people that see this particular set and you have one person that sees this particular set, so you make two separate data sources for them to use, but then you have an executive view that sees a combination of the both.
Mm-hmm.
Does it recognize the cross data as being the same database if you bring them both to the same project, or do you need to make a third data set that contains everything?
I think I do. So you do have two different data sources, and you're using either blending or cross-data source join to bring them back into one dashboard.
Underneath the hood, it's the same database.
Yeah.
And so you can do it with cross-database joins, but you want to keep them kind of segmented for the people who are accessing just their.
Yeah, so that's one of those cases that can we assume referential integrity for the table? So this view and that view, this may be using just a tiny amount of the tables on our data source. And this one may be using all of them, I don't know. So for that use case, if we're not assuming referential integrity, if it's not in the database, we are running the whole join. Potentially, we are creating data duplication, data loss. We have to be extra sure we have the right data. And yeah, maybe we could potentially just create a simpler data source for that use case. So one best practice is start small and create data sources based on the questions you want to ask, and then you grow from there. There's not like one huge data model that will answer all questions.
I would say it also depends on how exactly you're bringing them together. So if you just have one dashboard and you're using dashboard actions, then it's still okay to keep them separate and basically just like render them independently, and it's not actually going to affect performance as much. But if you do cross-data source join, then maybe a good idea would be to merge them into one single data source.
Yeah. So that's,
Is there any reason that you would not want to check the assumed preferential integrity box? It seems like it's all benefits. Is there any reason that you would want to leave that
Yes, there are cases where you basically can end up with incorrect data. So assume referential integrity means that there is something else that would guarantee this consistency between two tables. So there is some kind of an application that sits where you implement all the logic. That means that there is no order that doesn't belong to a customer or something. So there's something that's not outside of the database that enforces this. If you don't enforce it in an application somewhere else, then you basically can end up with incorrect values or inconsistent values. We've seen that as well. So test it, kind of handle with care. You wouldn't want to use it all the time.
Yeah, maybe the gentleman there.
Great presentation, by the way. Thank you for sharing all this knowledge and wisdom. Just curious, I know Hyper is fairly new. Any of this stuff you think might be nullified by that or performance-wise?
So the question is any of these going to change with Hyper? And we mostly talked about live connections. So really, at least the very first version of Hyper is just going to be a direct replacement for extract. So all this is still going to be applicable, basically.
All right, sorry.
You mentioned earlier about creating data sources for specific purposes and splicing up data sources in a file. I then ended up with like 20 different data sources in one singular file. Any suggestions for how to best manage when there's 20 different purposes for specific data sources or specific dashboards?
I need to look at it, maybe.
So you kind of, I mean, there is no, you need to find the right balance, right? You have two extremes. We've seen people trying to create one massive data source that can be used to answer any question possible in enterprise. You just end up with a connection with 300 columns and just not practical to use. Another extreme would be to have one data source per workbook or even per view or something. That is something that we wouldn't advise either. So it kind of work out. You need to find the right balance. I mean, it's really hard to give a specific recommendation around this.
Guys, we will stay here, and because we have to close the session. So just before I close, there's a repeat tomorrow. If you know anyone who would like to learn more about these techniques, it's in the morning. If they are not hungover, please ask them to come. And a couple of good sessions on best practices, the ones I mentioned before. There are two options, two slightly different sessions. And this third one is about another very interesting tool to check and automate performance testing. You can see how a user interacts with visualizations, and you can let it run automatically, and you can use for A/B testing. So there's a session on that. It's called Scout Tool. And please, don't forget to rate us. 5 star. No, I'm kidding. Honest feedback.